So, this is a 2017 question. The function f is such that f of x is equal to 2x cubed plus 5x squared minus 4x minus 3, where x is a real number. Show that x is equal to minus 3 is a root. So, your function is this, then when you put in any of your solutions, you should get 0 as your answer. So, if x equals minus 3 is a root, when we put in minus 3 for x, we should be getting 0. Minus 3 and minus 3. So this is minus 27 by 2 is minus 54. This is positive 9 by 5 is 45. This is negative by negative is positive. So that gives you 57 and minus 3. So you're getting minus 57 plus 57. So it's equal to 0. So that implies x equal to minus 3 is a root. So you have to find the other two roots. So by doing some long division, if x is equal to minus 3 is a root, then it means x plus 3 has to be a factor. So if you divide x plus 3 into 2x cubed plus 5x squared minus 4x minus 3, you get a quadratic that we're able to then factorize to find the other two roots. So x into 2x cubed, that gives us a 2x squared. Multiply that out, it gets 2x cubed plus 6x squared. And take that away from that, you're left with minus x squared. So x would go into minus x squared minus x times. Multiply that, you get minus x squared minus 3x. Brackets around it, take it away from each other. You're left with minus x minus 3. Multiply that by minus 1. You get minus x minus 3. And you're left with 0. So, factorize this. 2x squared minus x minus 1. Factorize that, you're getting 2x and x, 1 and 1. You're getting minus 2x and plus 1. So solve this here. You're going to get x equal to 1, 2x equal to minus 1, which means x equal to minus a half. So there are your other two roots. You've got x equal to minus 3, x equal to half, minus a half, and x equal to 1. Now, this is a cubic function, so it's a positive cubic function. It's no harm to just do a rough sketch to help you with the rest of the question. So I'm just going to draw it down here, and we'll go on and look at the question, see what other bits of information we have. We know that the first thing we know is that its three roots are at x is equal to minus a half, x is equal to minus 3. So this would be minus a half, minus 3, and 1. So if I was to draw that line there like that, you're getting that there is one root, x equal to minus 3. This is another root, x is equal to minus a half, and this would be x is equal to 1. So it's not drawn to scale, but it's good to have it drawn, right? So that's our linear x-axis. Now your y-axis is going down somewhere around here, where y is equal to minus 3. So I'll just draw it down here. Okay. Now, we've no idea how high it should have went here and how low it should have went here, right? So it's not drawn to scale, but it's just going to help you when you're working out this question. So it says find the coordinates of the local maximum point and the local minimum point of the function. So the local maximum point and the local minimum point are going to be down here, that's the minimum, and up here will be the maximum. And if I was to draw tangents through those points, the slopes of those tangents, because those tangents are going to be parallel with the x-axis, the slope of those tangents actually going to be 0. So you have the function y equals or f of x equals minus 2x cubed plus 5x squared minus 4x minus 3, and when you differentiate that you get slope. So you get this is a plus. You get 2 3s are 6x squared plus 10x minus 4. So that there represents slope. And when this here is equal to 0, it suddenly becomes the slope of these two tangents. So you make that equal to 0 and solve. Now divide everything by 2, you get 3x squared plus 5x minus 2 is equal to 0, and then you gotta look for factors. So it's going to be 3x and x has to be 2 and 1. It has to be plus 2 and minus 1. So solving that, you get x is equal to minus 2, and you get 3x minus 1 is equal to 0, x is equal to a third. So you get x equal to minus 2. So at x is equal to minus 2, which is somewhere over here, we can see graphically that we're producing our maximum turning point, and at x is equal to a third, which is somewhere over here, you can see that we're producing our minimum points. And just to prove that, if you go into your calculator and put in your function, create the into table mode, put in your function, and just say what happens when I put in start at a third. And end at a third as well. It's giving us minus 3.703. So this is the point down here, minus 3.7. That's the y value. So you can then put in minus 2 and you will get you'll get the higher start at, sorry, minus 2, isn't it? Start at minus 2, end at minus 2 as well. You're getting 9. Okay, so the local maximum point is the maximum point is minus 2, 9. The minimum point is a third, and your y value. Now, your y value, we've got 3.7, so it's something like, if you put it in here, you work it out as a fraction. It's something like 100 over 30 or 100 over 27, something like that. I'll just check that now. So 100 over 30, and we got 3.7, so I think it's 100 over 27, 3.703, that's what we got. So it was a little less than 30. So that's all I was doing with the 30. I was only guesstimating and then figuring it had to be a number less than 30 based on the fact that it was 3.7, slightly larger than 3.3, so I knew it had to be slightly smaller than 30. And obviously I was just trying to think of a number that prime number, well, not prime numbers but odd numbers, so I said 29 was too close, so I guessed 27. So again, I would work that out using pen normally, but because I'm using a marker, the marker is so much thicker. I'm using the marker for the camera, it's so much thicker, I'm using up a lot of space here very quickly, right? So like for me to write one line of maths takes up 4 lines on the sheet here. So again, just bear that in mind. Now, again, your little diagram that you've sketched will help you do the last part. It says if f of x plus a, f of x plus a, where a is a constant, has only one real root. So in order for this to only have one real root, this whole graph has to either shift all the way down so that it becomes a graph that just touches at one line like that. Well, actually, it doesn't. It has to shift up. It has to shift up enough. Yeah, sorry. So it either has to shift up, down, or it has to shift up enough. So if I draw this with so it has to shift up enough that this comes up to here. And it would only have one root here, and this came all the way down. It doesn't touch there, it has to come below there, and only has one root over there. So there are your two options. How far can our graph shift up or shift down? So what do we have to add on? So what are the range of possible values? So we have to add on, our function is 2x cubed plus 5x squared minus 4x minus 3. So we know it dips to minus 3.70 or minus 110 over 27. We know it dips that much under 0. That's the minimum turning point. So we need to add that on in order to clear the x-axis. So if we added that on, it would bring the thing up. So a has to be a number that is greater than this. So greater than 100 for 27, or it has to be a number less than minus 9. Minus 9 would bring this down. So if it was less than or equal to 9, it could touch here and still give us 3 real roots, 2 of which were the same. And if it was equal to 100 over 27, it would come up and touch this axis here. So we need it to be greater. So it needs to come up above the x-axis here, and it needs to come below the x-axis here. So that's that. Good question.